Today we're going to cover an extremely important concept in biomechanics, and that is external moment arms, how it relates to the load that you are moving and how it relates to the machines that you are doing exercises on. So Eileen's going to demonstrate us the first type of external moment arms. Once again, there's two types. There's one when we're doing something like a dumbbell curl, and then there's external moment arms that come from a machine because they have their own moment arm that dictates how much load is being applied to the system. So Eileen, if she does a bicep curl, and moment arm, once again, is the perpendicular distance between the load and the axis of rotation. That distance, the shortest line, is a moment arm. So if we're doing a bicep curl here, for example, the longest distance would be at this position from the load to the axis of rotation, which is the elbow. If you were to come all the way down to the bottom, you can see that line is now short, and now it's running in line with gravity. There is no moment arm at this point in the range of motion. Here, the distance is a little longer, here a little longer, here is maximal. So this is where the most load is being applied to her arm from the weight. And then as she comes up, that shortens again. So that's why you feel like at a bicep curl, it's heaviest right in the middle. Okay, so once again, the longest perpendicular distance. So if we're talking about external moment arms from weight, it's pretty simple when it's something like a dumbbell. But what if we're using a machine? We just covered what a simple system like a dumbbell moment arm, that external moment arm, what that looks like. But now we have a machine that we're adding to the system, which adds one layer of complexity. So now we need to remember the basic principles of load, axis of rotation, moment arm. So in this case, we have it not just from where the weight is being applied to Eileen's elbow, but how the machine is applying it to her hand, which is applying it to her elbow, and then what the bicep is required to overcome. So same principles apply. The longest distance between load to axis of rotation perpendicularly is where there's going to be the greatest load being applied. We just need to make sure we are now matching it up with how much Eileen's bicep can overcome in terms of load, how strong it is in that position in range of motion, which I'll cover in another video. It's called the length-tension relationship. So let's just break this one down real quick. So we have load here, axis of rotation of the machine. It is straight down. There is no load being added to the handle, and then therefore no load being added to Eileen's elbow. As she comes up, a little more moment arm, a little more moment arm. And now when we were doing the dumbbell, right about this 90 degrees is where Eileen had the greatest moment arm from that load, when she had to overcome the most weight. But here, there's not quite as much load as there would be right about here, okay? So this is the biggest thing when it comes to machines, is not all machines are going to be built the same. Not all machines are going to load like a dumbbell loads. That's why it's important to have different types of resistance in your programming, because they're going to train different parts of the range of motion. This machine is going to add the most load because of the longest moment arm, load, axis of rotation, when Eileen is just past that 90 degrees versus the dumbbell, where she was more 90 degrees and had the most load. So a little bit difference in the range of motion that's being trained here. So when you guys are considering choosing exercises, the external moment arm is a very important consideration. With something like a dumbbell, it's a little bit easier to discern. If you start working a machine into the equation, you just have to make sure you're taking into account the external moment arm of the machine and of her body.